Okay, so it's how to solve for this equation, the roots of this equation using the Newton-Raphson method. Now, this is the formula for the Newton-Raphson method. So you want to find the differential of the equation, which I've already done here. And sometimes they give you an initial guess, but sometimes they tell you to get an initial guess of where the root is. If you want to if they don't give you an initial guess, you want to use the bisection method. Basically, you assign x to random numbers, one to wherever. So x equals to 1. That's 1 cube minus 3 1 minus 4 is equals to minus 6, which is less than 0. Then we try to find for when it's not greater than 0. X equals to, that would be 2 cubed minus 3 times 2 minus 4 equals to minus 2, which is still less than 0. Then let's try x equals 3. X equals 3 at this point is 3 raised to power 3. At this point is 3 raised to power 3 minus 3 times 3 minus 4, which is equals to 14, which is greater than 0. So at this point we have a sign change. So we know the root lies in between this and this because that's why we have a sign change. So the root is in between 2 and 3. You get the midpoint. That'll be 5 divided by 2. That's equals to 2.5. So this can be an initial guess. It's pretty close to what they gave us anyway. So in case, this is just in case they don't actually give you an initial guess. So now using that, we're going to have x naught plus 1. That is basically x1 because it starts from x naught in this case. X1 equals to x naught plus f xn x naught, then f integral x naught. So in this case, we're going to have that x1 is equals to, what is x naught? That's 2. Then we're going to find f of 2, which is equals to, that's 2 cubed minus 3 times 2 minus 4. That's minus 2. We already got that before. And then f bar x naught, which is 2, is going to be equals to what? 3 times 2 square minus 3, that's equals to 9. So that we're just going to substitute into the equation. X1 is equals to 2 minus, sorry, not plus, minus 2 over 9, which is going to give us 2 plus 0.222222. Usually they'll tell you the number of decimal places that they want, so try not to be eliminating decimal places anyhow. If not, your final approximation may not be too accurate. And this is what you're going to get for x1. Now for the second approximation, which is x2, going to be equals to x1 minus f x1 f bar x1. So you want to find f x1. F x1 in this case, that basically best substituted into this equation. We're going to get 0.307269, and then f bar x1, which is this, substitute into this particular equation is going to give you 11.814813. So now x2 is going to be equals to what? 2.222222 minus 0.307269 over 11.814813, which is going to be equals to 2.196215. Now we're going to go to the next approximation, x3. That equals to x2 minus f x2 over f bar x2. For this particular one, f x2, which is this substituted into the main equation, which I have shown here, okay, going to be equals to minus 0.003803, and the second one, f bar x2, is going to be equals to 3 times this minus 3, which is going to be 11.470086. Now x3 is going to be equals to x2, which is 2.196215 minus 0.003803 all over 11.470086, which is going to be equals to 2.1958, which is going to be equals to 2.195823. Now for the fourth approximation, we're going to have x4 is equals to x3 minus f x3 f bar x3. In this case, f x3, we're going to simply substitute this into the equation. This is going to be equals to approximately 0, and f bar x 3 is going to be equals to 11.464956. Substitute this into the equation and you're going to get this as 2.195823 minus 0 over 11.464956. This is going to leave you with 2.1958 5,823. And you notice that this is equals to what we got last time. So now x3 is equals to x4. This is what we call the point of convergence. Therefore, we now know that our root final answer is 2.195823. You can also check it in your calc. You find out that this is very close to the actual root. Thank you for listening.